Welcome, and thank you for joining. This is a presentation of the Cover Cropping in the SGMA Era report. This QR code will take you directly to the report PDF. And this report was written by a group of experts and initiated to address the concerns of growers, agencies, researchers, and more about the impact of the Sustainable Groundwater Management Act, henceforth SGMA, on sustainable agricultural practices, and especially cover cropping. Since SGMA requires regulating the use of groundwater, folks wanted to know how much water cover crops use and if and how the potential restrictions on groundwater pumping stemming from this policy might threaten this multi-benefit practice. More information was needed about cover crops' net impacts on water, the ways water use was being accounted for, and how to ensure that they remained a viable management tool. For today's presentation, our goals are really to orient you to the high-level report content and to share a few key takeaways. We also want to create a foundation for you all on this issue to move forward from, whether your interest is cover crop adoption or how SGMA is being implemented. So before we center on the report, we'd like to connect on a common perspective that has emerged from this work. And that's that no one wants to see the implementation of SGMA leading to a Central Valley devoid of non-cash crop vegetation. So the effective implementation of SGMA will allow non-cash crop vegetation to remain viable. And the key questions are how and why. How do we do this? And why water managers and growers should care about practices like cover cropping, given the water scarcity in the Central Valley and San Joaquin Valley especially. So this report offers information and recommendations responding to just those questions. There's a huge opportunity to get this right. Water managers, GSAs, technical assistance providers, state programs, and more are interested and open to information to inform their action. So without further ado, let's begin the overview of the report and its contents. On the cover, we have a great side-by-side snapshot demonstrating key water benefits of cover cropping. So the picture shows adjacent orchards after a severe rain event, where the plot with bare ground on the left saw pooling and runoff, while the precipitation on the plot on the right with cover crops has gone all the way into the ground. And here are the report authors. I'd like to note that over 30 experts from a wide variety of sectors and institutions contributed to this report, including research institutions, state agencies, private entities, and beyond. So we'd like to thank them all for their time and expertise. To begin the report, we need to ground in the current context. And this starts with the fact that California is experiencing water dynamics such as prolonged droughts that are becoming more common, flooding of increasing severity, water quality degradation, and the overdraft of groundwater aquifers. In order to combat the final dynamic, groundwater overdraft, the state of California implemented the Sustainable Groundwater Management Act, or SGMA. So the next section of the report touches on the basics of this policy and its implementation, such as its centering of local control through localized decision-making agencies called groundwater sustainability agencies, as well as the requirement for basins to assess the total movement of water in their areas and make plans to avoid the negative impacts of overdraft, which in the most overdrafted basins in the state has meant the development of allocation plans, which aim to account for and regulate groundwater use. And while other issues like water quality are important, water quantity is what SGMA allocations are all about. So the report really focuses on the amounts of water. So in this context of SGMA, many growers, agencies, researchers, and more have expressed concern about the impact of this policy on sustainable agricultural practices, and especially cover cropping. But what is cover cropping? In order to answer this question, the report defines and explores this agricultural practice, points out its alternative of bare ground, and highlights the multiple benefits it can provide. So cover cropping refers to a broad set of practices. Generally, cover crops are cultivated vegetation that are used to protect and improve the soil between regular annual crop production or between rows of perennial tree or vine crops. In water-scarce environments, cover crops are often grown during the winter and rain-fed. The benefits of cover crops can include positive changes in soil health, pollinator habitat, carbon cycling, and water cycling. And while many people only think about their water use, cover crops can also provide these water cycle benefits, for example, by increasing the amount of water that enters the soil during a heavy rain. A vital point here is that these benefits depend on the context. Much of the research on these benefits comes from wetter environments, such as the Midwest. So if we're thinking about this practice in relation to sigma, it's vital that we use science from California or similar contexts. So in examining the intersection between cover crops and sigma, our report focuses on several key questions. What is the net impact of cover crops in California, and how can we minimize it? And by net impact, we mean the balance of cover crop water use and water cycle benefits. And the next question is, how are GSAs assessing groundwater use? And do these methods accurately capture cover crop water use and benefits? As a final piece of important background, our report then highlights the process that led to its development. This process included a 3-part convening series of experts that work with cover crops, water, and soils. In these convenings, about 100 participants discussed these questions, sharing their expertise and perspectives. And the intent was to build our collective understanding and connect different expert communities and knowledge bases. These convenings were supported by California's Department of Food and Agriculture, the United States Department of Agriculture, the University of California Agriculture and Natural Resources, California Association of Resource Conservation Districts, and Sustainable Conservation. So a big thank you goes out to them. With the need to share the important learnings of these convenings and continue to track down the unanswered questions, a collaborative writing process then began. In the end, approximately 30 experts contributed to this report, building on the collective work of all convening participants. So after laying out the background, we move into one of the major sections of this report. And that's the science section, covering the state of knowledge around cover crops and their net water impacts. The goal here was to synthesize existing information on cover crop water use and benefits for California relevant contexts. And this was done by examining published and in-progress research. And our review covers any water-related processes that might impact the movement of water in a way that's relevant for accounting for water quantity under sigma. For the purposes of this presentation, we are sharing those findings that are most relevant in answering that first key question. What is the net water quantity impact of cover crops? So the first half is then cover crop water use. This is an active area of research and a place where we will need to continue to build on the existing body of work. I'll preface by saying that cover crop water use can be variable depending on management, cover crop species, and environmental conditions. But the water use of cover crops is often measured by evapotranspiration, or ET, which is all the water leaving the ground or plants through the combination of evaporation and transpiration. So our big finding here is that there are circumstances where the ET, or evapotranspiration, of cover-cropped ground can be negligible when compared to bare ground in perennial and annual systems. And this is important because it's often assumed that cover crops will dramatically increase water use compared to their alternative, bare ground, but this isn't necessarily the case. On to the water benefits side. In the California relevant literature, runoff and infiltration are among the most consistently observed water benefits to cover cropping. Report contributors agreed that, based on the literature, a very conservative estimate is that infiltration is often increased by 40% or more, and runoff is often reduced by 40% or more. This is regardless of the slope or other environmental factors that could result in much greater benefits. This is a vital start, but it remains an area where we also need more information to better understand how we can consistently achieve even greater benefit. As the report has highlighted current science addressing the first key question, the next section addresses our second key question. How are GSAs assessing groundwater use of cover crops, and do these methods accurately capture their water use and benefits? To answer this question, we analyzed the policies of 9 GSAs in the San Joaquin Valley and followed up with interviews with GSA staff and consultants. The San Joaquin Valley was chosen as it has the highest concentration of critically overdrafted basins, and thus we could examine plans in further stages of development. A few important notes before we get into our actual findings. The first is that these findings we uncovered are not universal. They come from a small subset of GSAs. That being said, they do represent some potential trends and help us understand what approaches other GSAs may take moving forward. Next is that achieving Sigma mandates is complex, and GSAs are stretched for resources and looking for guidance. The findings do not reflect a lack of interest in these processes, but rather a lack of information, guidance, and resources to more deliberately address them. And we will not be diving in depth into these now, as we don't have enough time for the level of detail required, but we did want to share them. So much more context for each of these findings is detailed in the report. As we go through these findings, the text on the slides is the text coming from the report, and I'll just be explaining it in a bit simpler English. The first finding is that GSAs have been given a very difficult set of management tasks to complete. However, they haven't been told how to complete them and don't necessarily have access to the resources necessary. This has led to different approaches to managing groundwater and different levels of rigor in these approaches. Cover crops are not being explicitly penalized or fined, but GSA approaches tend to account for their water use without accounting for their water benefits. In reviewing these plans, certain underlying assumptions have emerged, whether implicit or explicit, and these assumptions do not necessarily reflect current science. One example assumption is that evaporation from bare ground is negligible, when bare ground can actually evaporate large amounts of water after precipitation events. We found an example where bare ground was a requirement in a specific incentive program. Such requirements for bare ground may still evaporate large amounts of water and can also lead to negative impacts on air quality, water quality, and human health. Effectively incorporating precipitation is critical in groundwater planning, but it's very difficult to do. Some of the approaches GSAs have taken to incorporate precipitation may result in unintended and unhelpful outcomes. The field of remotely sensed satellite ET, or evapotranspiration, estimates has increased dramatically, and more is being understood and assessed. However, a gap remains about how factors, such as more common cloud cover and higher amounts of bare ground, could impact the accuracy of these readings for winter cover crops. To assess groundwater use, GSAs use two main tools: satellite-based estimates of ET and flow meters. Conversations in the broader community often focus on which is more accurate or better, but what isn't discussed, and is equally, if not more important, is what is done with this data. Neither of these tools directly measure the use of groundwater, and therefore this variable must be calculated from their outputs. The ways that GSAs are performing this calculation are variable and not always rigorous. GSAs must account for massive amounts of water within their basin-wide water budgets. Think about the total amount of precipitation or the water use by agriculture in a basin. Due to management needs, these amounts, which are not necessarily accurate to many digits, are then subdivided and applied to individual growers. The quote-unquote precision introduced here is an illusion, and better accounting for this could create the operating space for more multi-benefit practices, like cover cropping. And our last finding is that this is bigger than just cover cropping. Current GSA approaches might have negative consequences for the success of other policies, programs, and efforts in the state. So, in summary, GSAs have an incredibly difficult set of tasks before them, and there is variability in how they approach these. In our sample, we found several trends in management approaches that make it difficult to incorporate the water benefits of cover cropping, and thus may unintentionally disincentivize them by only capturing their direct water use. These trends have implications beyond cover cropping and could impact on-farm, non-cash crop vegetation in areas of California facing more extreme periods of drought and flooding. So the question becomes, what next? How can we improve the implementation of SGMA and the viability of cover cropping within it based on what we've learned? To that end, the report articulates recommendations that will help establish the enabling conditions for cover cropping within SGMA, where and when it makes sense. Variability between GSAs and contexts mean that a one-size-fits-all solutions will not work, which is why these recommendations focus on broader foundational elements as opposed to specific recommendations for individual GSAs. By gathering and refining input from convening participants, contributors, and further conversations with GSA staff and policy experts, this report presents 5 categories of recommendations. In reviewing these categories, I will share an example or two of the specific recommendations that fall within, and more detail on all of the recommendations can again be found in the report. So the first set of recommendations revolves around research and includes developing, funding, and implementing a coordinated research program that addresses the most important gaps in knowledge. We have demonstrated that there are some consistent key benefits. Now, the opportunity is to better quantify these benefits and the conditions to maximize them while minimizing cover crop water use. The next set of recommendations include actionable pathways to directly address key gaps for incorporating cover crops into GSA planning. So these include developing and distributing guidance on the characteristics of water-efficient cover crops, as well as developing a spatial data set of cover crop adoption and making sure that that's updated at least annually. The third category of recommendations pertains to guidance for GSAs. This is so important in the context of resource-stretched GSAs facing considerable complexity. So we want to provide GSAs with the tools and frameworks they need to succeed. One specific rec here is to develop and distribute guidance documents on best practices and methodologies for complex processes GSAs must address, such as effectively incorporating precipitation into water accounting. The next category of recommendations centers improving the data and data access necessary for effective management. And this category includes evaluating and then investing in the most cost-effective ways to improve the distribution and quality of key ET data inputs. So for example, supporting the CIMIS network or investigating a new eddy covariance tower network. The final set of recommendations help to answer the question, how do we pay for all this? In the report, we highlight both short-term funding for specific finite recommendations, as well as the need to ensure sufficient long-term funding for GSAs. And that covers the major content of the cover cropping in the SGMA era report. Before we wrap up, I wanted to share key takeaways that go beyond those findings of the report and have emerged as key insights from the entirety of this process. Besides coming away with the general contents of the report and the means to read the full document, which I will share again shortly, we want to make sure you leave with the following messages. Cover crop adoption under SGMA depends on an accurate understanding of the net water balance of cover crops, which is that water use and water benefits. We have some numbers that we can use now as conservative estimates of water benefits: 40% reductions in runoff and 40% increases in infiltration. And the research community has a particularly important role in getting us to a better understanding of this balance and the conditions to maximize benefit while minimizing water use. Cover crops are not explicitly being penalized. We have been unable to find any evidence of fines or other direct penalties being levied against a grower simply because they have cover crops. And that was a concern that we were hearing. That being said, the approach many GSAs are taking could disincentivize cover crops because they incorporate their water use, but not the other water-related benefits like infiltration and runoff. GSAs have different resources, needs, knowledge bases, and therefore different approaches. And it's incredibly important for us as a community to understand GSA mandates and recognize the difference between individual GSAs, where they are in their process and what their approaches are. Support, rather than additional scrutiny or pressure, will be key to moving towards an implementation of SGMA that works for all. And this is complicated and new. GSAs need guidance, information, and resources. And they're increasingly asking for it. A unified understanding is important at all levels, between growers, technical assistance providers, GSAs, and DWR, and other agencies, in moving forward together. This report aims to build this understanding, and its recommendations outline a way forward. And our final key message, the practice of cover cropping has many benefits that are vital to California's sustainable agricultural future, especially in the context of our changing climate. Current patterns in the implementation of SGMA may create unintended barriers to realizing those benefits. And these unintended barriers affect cover cropping and other non-cash crop vegetation under SGMA. Therefore, pursuing the recommendations outlined here can help ensure the viability of this management tool and many others, like hedgerows, windbreaks, or filter strips, in supporting the health and sustainability of California's agriculture, environment, and communities in a rapidly changing future. So thank you all for your interest in this important topic. We encourage you all to download and read the report for the complete picture. There's much more depth than we could offer here. So to view the full report, please follow this QR code or visit our webpage at the URL on the screen. You can also find an executive summary of the report on this webpage. Please feel free to share this document across your circles. If there are any questions about the report and its contents, please do not hesitate to reach out to soils@suscon.org. Thank you all.